This is David Spears, Civil Engineering Instructor at Texas Tech University, talking about CE 2301 statics, reviewing exam number 2. We've got a three-dimensional moments problem. Here's the setup. XYZ axes. Point A is where F1 is applied. Point B is where F2 is applied. And point C is just this point out in space where we're going to take moments about and figure things around. Everything's in kilonewtons and meters. First problem was, what's the moment of F1, this force, about point C, way over here? Well, I want you to learn to refer to your equation sheet and let that trigger your memory of how to solve these problems. Well, the moment of a force F1 about point is R cross F. So I need a position vector from the point I'm taking moments about to the point of application of the force that I know. So I need a position vector R, A over C as we would call it, where A is the tip, C is the tail. I figure it this way. Subtract the coordinates of the tail from the tip, and I get negative 5i plus 9j plus 4k. Then I just need a little R cross F determinant, where it's unit on the top, position in the middle row, force on the bottom row. Evaluate that determinant, where this is the bottom row is F1, negative 2, 4, and 4. Evaluate that out. I evaluate that the way I do determinants, and I get 20i plus 12j minus 2k. Be careful, I've got to have my units kilonewton meters. Part 2 was moment of the force F2, which is this force down here about point O, the origin. My position vector, once again, I need one from O to B. It's real easy, it's just the coordinates of B because I'm subtracting 0 from everything. That's RBO. Put it in another determinant. Unit, position, force. Be careful on my force vector because it's just given to me as 6J, so I got to supply the zeros in the positive, in the proper points. Evaluate the determinant. I get 18i negative minus 0j plus 18k kilonewton meters. Part 3. I'm going to use another equation for my equation sheet. I want to know the moment of F2, the force 2, about the z-axis. Well, it's nice I've already got the moment about point O because that lies on the z-axis. So I go over to my equation sheet. I see the moment of a force about an axis is U, position vector, unit vector, dotted with R cross F. So I just need, I've already got R cross F, that's this up here, MO, the moment about point O. So I just need a unit vector in the direction of the z-axis, which is real easy because that's just 0i, 0j, and 1k. I dot that with this moment up here that I got, moment of force F2 about point O. And remember, when I do a dot product, I think it's on the previous sheet, I just multiply the I components times each other plus the j components plus the k components multiplied together. And remember, that's a scalar, it's not a vector, so I'm just multiplying numbers and adding them up. In this case it's real easy because I got 0 times 18, 0 times 0, and 18 times 1. So the answer is 18 kilonewton meters. Once again, I'm referring back and forth to my equation sheet to remind me of the vector mathematics behind it. Part 4, moment of F2 about the y-axis. Same kind of deal. I've already got the moment about the O-axis, about point O on the y-axis. So I just multiply I get a unit vector in the direction of the y-axis, which is 0, I, 1j, and 0k, and then I do the math, multiply the I terms times each other, j's and k's times each other, and I get 0 times 18, 0, 1 times 0, 0, 0 times 18, 0. 0. Then I realize, oh my gosh, the force F2 is in the pure y direction, which is parallel to the y-axis. Therefore, it creates no moment. Confirms my answer of 0. Part 5, the shortest distance from point O to the line of action of F2. I've got all the numbers, I just need to figure out how to calculate it. I look on my equation sheet, I see M is equal to FD, and these are all scalars. The scalar magnitude of the moment is equal to the force magnitude times the d distance, and that is the shortest distance. Rearranging, I just need to figure out what the magnitude of M is. Magnitude of force 2 about point O. It's the square root of the sum of the squares, 18 squared plus 18 squared, divided by the force magnitude. It's pure y, so its magnitude is 6. So it's that 6 square root of 648 over 6 is 4.24 meters. Last but not least, the magnitude of the moment of F2 about line OC. I go over to my equation sheet, moment of force about an axis. Well, OC is an axis, it's a line. So I just need a unit vector in the direction of OC. And I can get that by, it doesn't matter which one I start from or go to. I can just go, I want to do the easy one, 5, -5, and 0. Subtract 0 from all those, I get that. Divide by the square root of the sum of the squares. Here's my unit vector, UOC, which I want to dot with MO, which I've got up here, the moment of force F2 about point O. And I multiply the i's times the i's, I get 0.707 times 18. 707 times 0 is 0. 0 times 18 is 0. So I get, just do the math, I get 12.7 kilonewton meters is the scalar magnitude, which magnitude means scalar. It should make you think that. So that's the answer.